Hello and welcome to Upside Down World? Stranger Things? I'm not too sure. Do not worry. This is still math. Today we are going to be looking at adding and subtracting radicals and taking a look at, in challenge section, about figuring out square roots by hand. Yes, by hand. No calculators will be needed. It is not magic. Do not worry. Okay. Roll those dice, watch out for the Demogorgons, and here we go. Do not worry, we are not going to the upside down. We are going to add and subtract radicals today. And we're going to go back right away. And first off, a hint, if you're watching this video and you're maybe tuning in for the first time, see in the bottom right-hand corner, you have some options there to watch these videos at different speeds. And a certain drummer gave this tip. If you speed this up to 1.25, you can still somehow understand me, and it's going to save, yes, you're right, 25% of your time watching this. So you might want to do that. Still use the power of the pause. If something is a little bit confusing, you can always rewind. But yeah, if you're looking to save some time, bump up the speed, and hopefully I don't sound too much like a chipmunk. Here we go. Before we get into adding, subtracting radicals, we need to go and review this idea. And this was just combining like terms. And if I asked you to go and combine like terms, you would have said that, oh, the x's were the same, and I'd go and combine those. And notice how I always circle the sign to the left. It always makes life a little bit easier. So if I went and combined those, I would have had 9x plus 2y. I'm allowed to combine things that have the same variable with the same exponent value. So you can combine those x's, but for instance, let's say you had like 5x squared plus 7x. You couldn't combine those because x squares are different than x's. So we're going to use that idea as we talk about adding, subtracting radicals. Let's start off nice and simple. Let's just say that you had let's say 2 root 3. So 2 root 3 plus 5 root 3. I want you to think of the root 3. So I want you to think. So here's a little kid, and this kid is thinking about radicals. And I want you to think of this question as 2x plus 5x. So what I've done there is I've replaced the root 3's with x's. So when you're thinking about combining or adding, subtracting radicals, the radicand has to be the same in order to do that. Just like with variables. So these are both these terms are root 3's. So I just want to know how many root 3's are there? Well, there's 2 plus 5 root 3's. So we say there are 7 root 3's. Make sense? On to the next one. Let's say you had something that was maybe like this. You had 5 root 2 plus 3 root 3. Actually, let's make this a minus 7 root 3 plus root 2. Okay. So we have two different kinds going on here. We've got root 2's going on, and we have root 3's going on. So let's deal with the root 3's right now. Why not? Let's do that. It'd be kind of fun. So you'd have 3 minus 7. So it is minus 7 root 3. And you would also have plus a 5 plus 1 root 2. So where's a common kid mistake? A common kid mistake is forgetting that there is a 1 right there. There's a common kid mistake. There's a 1. That's where that 1 came from. The other common kid mistake, which I a little bit addressed, is forgetting about this minus sign. So forgetting that minus sign is right there. So what's your final answer going to be? It's going to be negative 4 root 3 plus 6 root 2. Some students will always ask, could I have wrote 6 root 2 minus 4 root 3? For sure. Go ahead, go crazy. That's totally okay. So that's the basics of adding, subtracting radicals. And now we're going to go and kind of revisit an older topic and combine it with this current one. So remember the whole thing about simplifying radicals? So you remember that whole thing, like if you had the square root of 12 and you had to go and simplify that, you always have to simplify that. That would have become root 4 times root 3. I remember you could have wrote root 3 times root 4, but if you get into the habit of writing the square number first, it becomes really easy for you. So the square root of 4 is 2, and this is just root 3. So root 12 simplifies to 2 root 3. Okay. Well, let's go and combine that idea with adding, subtracting radicals. Let's say you had a question that was this: 3 root 8 plus 5 root 2. So if you look at this and you say, I have a root 8 and a root 2, I can't combine those. But you could go and simplify those. Yes, you could. And that would become 3 times the square root of 4 times the square root of 2. And 3 times, basically, 3 times 2. So this becomes 6 root 2. Don't forget you still have this. And that becomes 5 root 2. So now we have common roots. That's exciting. So this is 6 plus 5 root 2. So your final answer is going to be 11 root 2. So using the idea of simplifying to get common radicands that you can go and add and subtract. Last question. And the last question is going to be a doozy. It's going to be exciting. It's going to be the Demogorgon of examples. You know, when I was your age, we would always play Dungeons and Dragons. And we didn't have smartphones or anything like that. And we would sit there and roll those 20-sided die. And it was fun. I don't know if it's going to become back to being popular again with the popularity of the TV show. But good times. Demogorgons. It sounded scary. Let's go and simplify all these, because you have root 18, root 27, a root 3, and a root 8. Nothing is, absolutely nothing is common. So I'm going to go and simplify this, and hopefully you guys know this is 9 times 2. So this becomes 3 root 2. Over here, this would become 9 and 3. So that would be 3 root 3, times it by that. So it would be negative 6 root 3. Over here is still positive 3 root 3. Nothing happens there. And this would be 4 and 2. So this would be minus 12 root 2. So what I've done there is I've gone and simplified everything. And now I have common roots. So I can go and combine kind of like my like roots to get a final answer. So let's deal with the root 2's. 3 minus 12. So that's going to be negative 9 root 2. And negative 6 plus 3. That's going to be minus 3 root 3. And that's your final answer. There you go. Adding and subtracting radicals. So you can go and practice some more questions, or you can go and look up some Dungeons and Dragons and start developing your own role-playing game. Up to you. Have a great one. On to challenge.
See, that wasn't too bad, now was it? In the challenge section, you are going to be amazed. We're going to go back in time to grade 2, figure out some stuff of how we did long division, and apply that to figuring out square roots by hand. Yes, you will be a human calculator. Let's get to it.
We've talked a lot about going back into the olden days and playing Dungeons and Dragons. Well, imagine back in the day and you didn't have a calculator. I know, the shock, the horror. How would you possibly survive? So we are going to look at those dark days and taking a look at figuring out square roots by hand. Yes, square roots by hand. So like the square root of 10. How would you go and figure that out if you didn't have a calculator? We're gonna go and figure that out. So it's gonna be so much fun. You have to bear with me here. We're gonna use the idea of long division a little bit. So if you had like 8 divided by 6. So this is back in probably what's that, grade 2? You go 6 times 8, and you say that's 1, and you did the multiplying, you did the subtracting, and then you had to go and, create a decimal. It had to go up there. Then you had a 0 that you could bring down. Then you went 6 times 20, and by this time, you're like, whoa, this is cool. You bring down another 0, and you put another 3, and you started to see that that's going to be 6 point, or, keeps going. 6 times 3 is 18, so you get 1.33 repeating, so it's just going to be like that. So we're going to use that idea in talking about figuring out square roots by hand. It's going to be pretty impressive. This is going to be a pretty impressive thing. You're going to be like, wow, I just learned this. The example we're going to use is the square root of 91. So the first thing is, how do you set things up? This is really important. So I'm going to kind of start over here, and you're going to start off by always setting up kind of like a little table like that. It's a little table basically. And I'm going to put 91 over here. So I'm going to put the 91 right here. And the first thing you have to think about is squares and square roots is kind of dealing with things that times by itself. So like the square of 3 is 3 times 3. So you're working in groups of 2. So one of the biggest differences is, remember back in grade 2, you would bring down a 0. Well, you're going to work in pairs always. So we're going to work in pairs of zeros. That's a really important thing to think about. Okay, let's get to it. First thing you have to be thinking about is what number squared will get you really close to 91. Okay, so maybe you're thinking, oh, I wonder if 8 times 8 would work. Well, 8 times 8 is 64. Can I get closer? How about 9 times 9? Well, that's 81. That's pretty close. And 10 times 10 is 100. That's too much. So the Goldilocks number you wanted to choose was 9. So you got the first one, which is great. So you're going to put that 9 right here. So far, so good. Are you with me? Excellent. And you know that 9 times 9 is 81. So I'm going to write down that 81 right here. And I'm going to do my subtracting. And when I do my subtracting, 91 minus 81, so I'm subtracting, is 10. And I'm going to bring down these pairs of zeros. That's really important. And don't forget, I had a decimal right there. So my decimal is going to go right here. Okay, now what? Whoa. Okay, so now what are we going to do? What are we going to do? Well, it's going to be the same kind of idea a little bit. But here's the trick. You need to, so for the next thing is going to deal with 1,000. So you might be thinking, oh, well, what number times itself will give you closest to 1,000? Not quite. Okay, it's not quite like that. What you're going to be doing is saying, I'm going to double this number here. I'm going to double it. So what's 9 doubled? 18. And it's going to go down on the next line. So what does that look like? Well, here we go. So I'm going to go and do another line. And I'm going to put that 18. So there's 18. But I'm going to put blank times blank. And that is going to be less than, it has to be less than 1,000. So that's what the 1,000 is going to play in. The blanks have to be the same number. Okay, so the same, I'll say, maybe not number, I'll say same digit has to go there and there. So 180 something times something is less than 1,000. That's what you need to be trying to figure out. So this is why you always need a lot of room for these kind of questions. Because, I don't know, my 180 some odd times tables, they're not that strong. So let's say you were thinking, I don't know, maybe 184. So 4 is the digit I chose, times 4. What's that going to look like? So you're going to go here, and you're going to use long, kind of your multiplication skills, and you put a 3 there. So 736. Well, I think I can go bigger. How about 185 times 5? Could you go and do that? Well, that's going to be 925. And just using some mental math, you're like, yeah, that's the number. So it's going to be 5. It's going to be 5. So up here is going to be 5. Cool. So you got 925. And you're going to do your subtracting, which is going to be 75. Now you're going to have another pair of 2 zeros come all the way down. So 7,500. Go back to the same idea of you need to double this. So you have to double 95. So you have to go and double this number here. And if you double 95, realize I didn't say 9.5. 95. That's really important. If you go and you double that, you're going to get 190. So let's go and set that up. So I'm going to get 190 blank times blank has to be less than 7,500. Again, my 1900 times tables aren't that good. So you're going to have to go and probably experiment a little bit. So I would go and say maybe 1902 times 2. How much is that going to be? So 4, 0, 18. So 3804. That's quite a bit less than 7,500. I think I can get a little bit closer than that. So, maybe you tried 1903. Times 3. Spoiler alert, this might be the number that you're going for. So this is 5704. And that is the number that it's going to be. So I'm going to put my 3 up there. I'm going to put the, that's the digit. And you put your 5704. And you do your subtracting. Like that. And what does that end up giving you? I love subtracting. Subtracting is so much fun. There's 6, 14, 7, and 1. 1796. And you've gone to 2 decimal places. Now that's pretty good. If you have a teacher like myself, that's as far as I'd want you to go. But you could keep going. You would go and double 953. You would double that and write it down here, and blank times blank would have to be less than 1796. So that's how you kind of keep going with this. That's the kind of idea. So that is figuring out square roots by hand. Hope you enjoyed.
Thanks everybody for tuning in for another episode of Mr. Douglas's Math Stuff. I hope you enjoyed it, and I can't recommend enough this TV show. It is fantastic, and after you do your math practice, go check it out. Alright, till next time.